Hello students, so welcome again, welcome another lecture on projection of a straight line. If you remember in earlier videos we have discussed the simple cases of all the straight lines. Now today I want to revise all those cases and to finalize the concepts about the straight line. So if you look at this figure, we will start from the first figure. This is our first line, that is the first case when the straight line will be parallel to both the plane. As you remember that whenever a line is parallel to both, we know that its both the projections are parallel to the reference line. Again I have taken the line that is parallel to HP and VP both. This equal sign means the distance of A dash will be equals to distance of B dash. The same way the distance of A will be equals to distance of B. So this is the first case when the line is parallel to both. As you know that whenever line is parallel to both the plane, both the projections will show the true length, and this is one of the simplest line. So we will tell that that is the simple position of a line. Then the second case we already discussed, that will be the straight line which is parallel to one of the reference plane and contained by the other plane. The two options will be a line can be parallel to HP and on the VP, or maybe on the VP and parallel to HP. So look at this first case. This line, as the top view will be on the XY line, it means that line will be on the VP, and as it is parallel to HP, so this front view A dash B dash will be parallel to reference line, and again in this case the front view as well as the top view both are showing the true length. Third case, the reverse of that, when the line will be on the HP and parallel to VP, you know that when the line will be on the HP, its front view will be on the XY line, as it is also parallel to VP, so top view will be also parallel to the reference line. Again in this case we are getting true length in both the projections. So these are the similar cases. So what the concept we generated, whenever line is parallel to one of the plane, its projection on that plane will show its true length. Same way the similar will be if a line will be on contained by a plane, the projection on that plane will also show the true length. So these are the two cases in which in both the cases we are getting the true length. Then the third case, if you remember, third case we have taken, that will be when the line will be inclined to one plane and parallel to other plane. If again I will use this stick, then this is the first case when the line will be inclined to HP and parallel to VP. So when it is parallel to VP, so the front view will be again showing the true length, and this inclination theta, that is also seen in the front view. So this is the case. So this angle will be theta, and this theta, as you know, that will be the true inclination of the line with the HP. When this is theta, it means that length is also true length, and because it is parallel to VP, so that AB will be parallel to the reference line. So this is the case when the line will be inclined to HP and parallel to VP. The reverse of this will be if I move the stick like this. Now this line will be inclined to VP by some angle phi and is still parallel to HP. Now this time the top view will show the true length and also the inclination phi, and front view will be shorter. So this is the case. Now in this case, if you see that in the top view we are getting the inclination, that is the inclination phi, and this length will be true length. Again this time the front view will be parallel to the reference line, and that is shorter than true. The similar to these two cases will be, instead of making it parallel, we can contain the line on the VP or maybe on the HP. One case I can easily show you here, that will be like this, when the line will be on the VP and inclined to HP. So this case will be drawn here. This line will be on the VP, so top view, in this top view will go on the XY line like this. So this is the case when the line will be on the VP and inclined to HP again by some angle. That angle will be theta, that is the real angle of the line with the HP, and this length will be again true length. In this case also, if instead of making it parallel to HP, I can keep it on the HP and making it inclined to VP, then this front view will come on the XY line. The case will be like this. So this is the case when the line will be on the HP and inclined to VP by some angle. Again the inclination with the VP will be seen in the top view, and this length will be true length. And the fifth case, which we already know, that will be when the line will be perpendicular to one of the plane, like this. If I hold this stick like this, now it is perpendicular to HP, so automatically parallel to the VP. Again the front view will be true length. This time the front view will also perpendicular to the XY line, and top view will be a point. So if you look at this figure, this A dash B dash will be the length, and this will be the true length of the line. So this is true length, and its top view will be a point. That is also known as point view of a line. Reverse to this, if I hold this stick like this, now the line will be perpendicular to VP, parallel to HP, so top view will be a line showing the true length, again perpendicular to the XY line, and front view will be a point. So the figure will be like this. This AB will be its true length again, and this front view will be a point. One concept in perpendicular line, the point which will be away from the reference line, or you can say away from the plane, will be visible in first angle projection. So as A dash will be away from the XY, so in the top view A will be visible, B will be hidden by A. Reverse case, in this case when the line will be perpendicular, as this B will be away from the XY line, so B dash will be visible and A dash will be not visible. So in this case maybe we will write B dash first and A dash last. So that is the way. So these are the actually 5 cases already we discussed. I just want to read something again important. What is common between all these 5 cases will be, in all these 5 cases the line will be at least parallel to one of the reference plane. So maybe I am getting my first concept कि we can get true length and true inclination when the line will be at least parallel to one of the reference plane. As in this case also, this line is perpendicular, so automatically parallel to the other plane. So we are getting the true length. One more way to read the problems like this, if you look at this figure, in this A dash B dash is parallel to XY, in this case also A dash B dash parallel to XY, in this case also A dash B dash parallel to XY. So all these 3 cases the line will be parallel to HP. So what the concept we earlier generated, that front view always relates with HP, top view always relates with VP, that is also true in the case of a line, as that is true in the case of a point. So if you want to read any line, if the front view looks parallel to XY, it means line is parallel to HP. These 3 cases line is parallel to HP. Now in this case, AB is parallel, AB is parallel, AB is parallel. So means these all 3 cases the line is parallel to VP. Same way, if the line will be on the HP, as in this case you see that A dash B dash will be on the XY, in this case also A dash B dash on the XY. It means in both the cases the line will be on the HP. Reverse, if AB will be on the XY as in this line, and another case will be AB in this case, so in these 2 cases the line will be on the VP. So simple concept will be, if front view is parallel to XY, line is parallel to HP, top view is parallel to XY, line is parallel to VP, front view will be on the XY, line is on HP, top view will be on XY, line will be on VP. Same way reverse inclined case, if the front view will be inclined, it means the line will be inclined to HP, and that angle will be also theta. If the line will be inclined to VP, so top view will be also inclined to VP by some angle phi if the line will be parallel to the other. Just the different thing will be in the case of perpendicular case, whenever a line is perpendicular, it will be also seen as perpendicular line. So when the line will be perpendicular to HP, front view will be perpendicular to XY. If the line will be perpendicular to VP, top view will be perpendicular to XY. But in these 2 cases, we also see the other view also, that other view must be a point view. So if the other view will be a point view, then you can easily understand we are getting the point only when the line will be perpendicular. And if the line will be perpendicular to HP, its top view will be a point. If the line will be perpendicular to VP, its front view will be a point. I hope in this way you can easily read the problems already drawn in the drawing. For drawing purpose as well as for reading purpose, these concepts are very useful. So write down these concepts what I told you in your notebook and use those concepts for drawing the problems. Thank you very much.